Tech-Vented.
What I'm about to show you now is going to blow your mind. I repeat, read my lips. This is going to blow your mind. This is a 3D printing machine. We are bringing this technology to you to make sure that you are familiar with this machine as well as the capabilities of what this machine could solve. This is a 3D machine. As you can see, I'm clicking on the print button here to make sure that we start the print. And before this machine starts printing, it has to do a couple of checks here and there. It has to ensure that the bed is very hot, as well as the nozzle where the plastic will be coming out is also well heated before it starts the print. And here right here, it is now configuring it's trying to know the place where it is at the moment by trying to see, okay, how far am I from the bed? The bed is the plastic, the metallic substance you are saying here, this flat surface is the bed. Is trying to know, okay, where am I currently on this particular bed? How far am I from the from the x-axis? How far am I from the y-axis? And it will now reconfigure itself in such a way that it will now fully get in its own memory the entire location of the plate to know the size of the plate. Okay, this is the box I'm being given to print on. Then it's trying to know the height. Also, can you see it's checking the four corners of the plate to make sure that it will not go past that particular plate once it starts printing. This is just mind-blowing. So after understanding this, then it will now do the filament check to see whether the filament would come out. When I say filament, it's actually the 3D strip, the plastic strip that we feed into the 3D printer. And right now it has started the printing. It will firstly lay the first layer. Then trying to lay the first layer. How this machine works is that it has a couple of coordinates in mind, whereby it during the slicing process, where it is preparing the model to know how to print it. The model with this particular model you are seeing will now be converted into a couple of X, Y, Z coordinates, which the machine can use to move at precision to a particular distance over time. So this is what it will now be using every seconds to just move from move X 30, Y 50, and Z 10. Then after moving that particular direction, put the plastic there, then move X 15, Y. So this kind of coordinates is what it will now be using to be moving at different places. And as it is moving, it is kind of ejecting the plastic. It is releasing the plastic on the object is already printing layer after layer, layer after layer. And this is just very mind-blowing. If you are with this machine, you can just watch it print for several minutes and kind of still be amazed by the speed it has, as this is one of the fastest machine in the world. So this is Creality K1 Max right here in Nigeria printing for us, and this particular print we are making is actually a test print, because for every new printer you want to know whether the printer can print a complex object. In trying to do that, there are a couple of follow-com print models that came with the printer. The one we selected here is the canoe. So it's trying to print a canoe, and you can see the percentage is like 20% of the 11 minutes of the print. So this means that the canoe is actually going to take like 11 minutes. And why I we selected this particular canoe? Because we have a couple of other different models that we can print with. We've selected this canoe because it's actually the least time in the list of the different models we can print, and because we are trying to manage the plastic we are trying to manage the 3D filament which we have for more important projects. As this is just a test print, we want to see whether this particular printer can print a complex object, and in trying to do that we need to use something. So that is why we just use this canoe, this 3D benchy hyper PLA is the 3D bench hyper PLA is the kind of PLA we are using, and this canoe is what we are printing. The layer is coming up, everything is just forming. It will print a particular extent here, then leave that and go elsewhere to print and resume back there without any mistake. This is just very powerful, and we can't wait to see us having more of this kind of machine to ensure that we are able to transform our creative idea into reality. This is just mind-blowing. Let's just wait for it and see how soon it can completed. So for now, we'll just ensure we fast forward the video a little bit to ensure that we can be able to fit all the whole 11 minutes into this short time we have to save us the time. But let's just watch it and see how it's printing. This is just kind of very cool to watch, and it's mind-blowing. Yeah, it's almost done, 65%, and as you can see, the fan, cooling fan on the side is rolling to ensure that the temperature is very very controlled and nothing gets overheated over time, which will just melt down the entire plastic. So 85%, we have less than 3 minutes to go on this print, and the machine is making sure that it prints the roof of the canoe to ensure everything is well intact. Is yet to complete the base. As you can see, some spool is kind of just around somewhere there, which means it will resume there shortly. Yeah, 50 degrees Celsius, 220 degrees Celsius, yes, and the okay, 50 degrees Celsius on the bed and 220 on the nozzle heating. So it's melting the plastic, the 3D filament you are providing to it, it's melting it at a temperature of 220 degrees Celsius, and the bed, which is the metal plate where all the printing is on, is actually being heated up to 50 degrees Celsius, because each filament has its own temperature range. There are certain filaments that if you should use a particular temperature with, it will not give you a very good print. You just see the print not printing correctly, and everything will just melt down, be fused together. It wouldn't give you the finished look we are looking for. So each filament, each type of plastic has its own temperature as well as bed temperature setting, nozzle temperature and the bed temperature setting. So depending on the plastic we want to print, we have to specify this. But given that this is a follow-com model we printed, all of those specifications has been built in, so we don't have to worry about that. So down the line, we are going to be learning how to create our own 3D models, and we are going to be showing you how we are using that to solve real life problems, because that is one of the reasons we have this channel created.
Tech Vented.